I asked ChatGPT, tell me the one programming concept that has contributed the most in making developers' life easier. And the answer was abstraction. If this confuses you, let me clarify one thing first. Abstraction is not just limited to OOP. It's a very broad concept and it's present everywhere. I'll explain this in a while. Next, I asked a few of my colleagues to run the same prompt from their own accounts. And interestingly, the answer remained the same. I didn't stop here. Then I asked Copilot, what is the most important programming concept? Abstraction. Then I asked DeepSeek, most important programming fundamental. Again, abstraction. Then Gemini. I tried these different models, and more than 90% of the time, the answer was the same: abstraction. Why don't you try it yourself and share your response in the comments? I'll pin my exact prompt in the top comment. And now I will tell you the top 2 reasons to explain these answers. It makes things possible by hiding complexity. Abstraction is the act of hiding the underlying details behind an interface. How it works? You keep the underlying entity with all its complex internal details hidden, and you expose a simple interface for interaction. Now, anyone who wants to interact, they don't interact directly. Instead, they interact using this interface that allows them to interact with the entity in a user-friendly manner. Take a car, for example. The actual internal workings of a car might be very complicated, but those complex mechanics are hidden behind a user-friendly interface. We use a telephone to make calls, but we don't need to understand how our voice actually travels across the world and reaches the other person. All of that complexity is hidden. The same idea applies to programming. When you use a method definition to call a method while the underlying method body remains hidden, this is abstraction. You can use a C# interface to interact with a class without actually referencing the concrete implementation. We use an API to call a backend without knowing the actual backend implementation. This API is an interface, and the backend is the underlying implementation that remains hidden from the API user. We use a SQL query as an interface to fetch or update data, and the underlying implementation is abstracted away. Now pause for a moment and think carefully. Abstraction does not only make things simple for us, it actually makes things possible. It's almost impossible to deal with all that complexity directly. Just imagine, how would you dial a call or drive a car without those abstractions? Similarly, without methods, classes, and APIs, how would you interact with the underlying system? We would have to deal with all that complexity every single time. If someone had not created SQL, we would have to reinvent database interaction in every single application. So abstraction not only reduces complexity, it makes things doable. On top of that, it allows you to build on top of existing abstractions. SQL is an abstraction over an underlying database. An ORM can be another abstraction on top of that, then a data access layer. Similarly, we may be using some third-party services. Their APIs are abstractions over those systems, wrapped by another layer of abstraction in our code. We may have more abstractions over cloud storage, over caching, and so on. Then we have a business layer as another abstraction, which uses all those underlying abstractions. Then an API layer on top of that. And interestingly, all of this can itself become a third-party system for someone else, acting as just another abstraction in their system. That system does not need to deal with all that complexity that we have dealt with over the years and are still dealing with. All they have to do is use a simple interface. That's how abstraction makes things possible. If you look carefully, we are surrounded by thousands of such abstractions that we use on a daily basis without even realizing it. Just think about it. Someone has already implemented this method. Now we don't need to solve the same problem again. We can simply reuse it by calling this method and move on. Similarly, someone has already built a DBMS for us. Someone built GitHub. Someone built the cloud for us. Imagine how difficult it would be to do all of this from scratch without these abstractions. To better appreciate this, let's try to visualize it. What happens is that we face different challenges as a community. Then someone from the community solves that problem. And then they make their solution available by wrapping it inside a simple interface. Now everyone can use it without going through all those challenges again and again. Each tool that we use, each framework or library that we use is basically a set of such abstractions. In fact, you will hardly find a design pattern or architecture that doesn't involve the concept of abstraction. Abstraction is literally everywhere. A line of code as simple as an initialization or assignment involves multiple layers of abstraction. Just think about it. Under the hood, we have binary, then machine code, then intermediate language, then high-level languages like C# or Java that we use to write code. All of these are layers of abstraction. Each layer hides the underlying details and makes our lives much easier as developers. Imagine how difficult it would be to write everything in binary if there was no abstraction. I hope now you can see the reasoning behind those replies from the different AI models. I hope you can now see how practical the concept of abstraction really is. That's why I believe abstraction is the most important programming concept. If you ask me the one programming concept that you must master, I would say that should be abstraction. Though an average developer, as I said, use hundreds or even thousands of existing abstractions on a daily basis, they hardly ever create their own. Even when they do, since they don't understand the abstraction design principle that says design for users, they design them incorrectly. What we need to understand is this. You can't just hide any detail and call it an abstraction. Abstraction is not about hiding things in any way you want. No, there is a key principle that explains how to correctly design an abstraction. I'm going to cover all of this in this season. And because of all these reasons, I chose abstraction as the topic for the season 2 of the Code Like an Architect series. Now, before I end this video, just try to visualize how amazing our code could become if we hadn't abandoned the use of abstraction in our day-to-day development. Just imagine developers facing challenges and then solving them using abstraction so that no one has to go through the same problem again. This would take our day-to-day coding to another level. In this season, I'll actually show you how this happens in real programming scenarios.